Welcome to AP Calculus. Is there an echo? We got kicked out. We got kicked out of our studio, but we found a closet to do our thing, and here we are. That's right. Calculus must go on because there is an echo. If there's an echo, it's because we're in a closet and we're having a good time in that closet. Because we are doing math, that is why we are having a good time. How many days left do we have until AP Calculus is on? 35! I'm going to have fun yelling today. 35 days, 5 weeks. It's almost here. Anyway, all right, we're doing practicing area and volume problems today for you, the calculus student, the viewer. And I understand we have the great Scott Hill or Kittner from Hillcrest High School. Which one?
Kittner, I told him this time.
Oh, okay. How you doing, Scott?
I'm doing good. I'm here with Laura Pearson and Dow Tate.
And Dow Tate. Are you in the journalism room?
Yes.
Tell the great Mr. Tate, the National Journalism Teacher of the Year. National Journalism Teacher of the Year. That's pretty impressive. That his little journalism soiree this weekend is causing people to lose extra credit. But I bet he really doesn't care, does he? Why don't you get Mr. Tate on the phone for a second?
Oh, I'm here.
See, Dow.
Yes.
You know, what is this here? I thought we were going to a Maverick game.
Well, you're the one that's tied up all the time.
It's okay. It's all right. I know you're too important.
I know your wife.
I know you're too important. I know you're too important. All right, get Kittner on the phone.
No, you kind of bashed my program on like this district-wide television. What's up with that?
District-wide. National Journalism Teacher of the Year here. Okay.
Okay, wait, first off, where are they watching this program? I'm allowing a journalism room to see a calculus program.
Okay, all right. I'm glad you're supportive. Get Scott on the phone.
Thank you very much.
Hey, Scott.
Yes.
All right, you're going to have to earn it, buddy.
Okay.
All right, here you go.
All right.
National Journalism. That's pretty impressive. Let R be the region bounded by y equals square root of 2x and y equals 4x. Find the volume if R is rotated about the x-axis, Scott. Okay?
Yes.
So you're up. For the money. Show him the money. Is there an echo, Scott?
A little one.
Okay. How about if I yell?
Not really.
Okay.
Do we get to use calculator?
Well, let's try it without a calculator first. What would you do if you did not have a calculator?
You want to find the points of, you want to find the limits.
Okay, so very good. I like that. Calculus lingo, limits.
So find the points of intersection.
Well, how do I do that without a calculator?
Set them equal to each other.
You are truly the man. So you set them equal to each other. And what do you do from here?
Put everything on one side and square it.
Well, how about we square it first?
All right.
So we get 2x is equal to what?
16x squared.
And now what do you want to do?
Move 16x over with the, move the 2x over.
And now what do we do?
The 16x squared what? What's the plus 4?
What do you do?
Is this right? 16 squared plus 4x? Yeah. All right, then we're going to factor out a 4x. Oh, I'm sorry, 2x.
What do you want to do?
Factor out a 2x.
Factor out 2x, okay, so what do you have left?
8x minus 1.
Okay, so then what are the limits? You're doing great, Scott.
0 and 1/8.
The 0 and 1/8, okay. So which curve's on top?
Is that right?
How would you know? You're right, it's 0 and 1/8. How do you know which one's on top, Scott? Scott?
We know 4x is a line, but...
So 4x is a line. What's the y coordinate at 4, and when x is 1/8, what does y equal?
1/2.
Very good, it's 1/2. Okay, so that we know that's a line. So square root of 2x, how do you know if that can be on top or bottom?
That's going to be on bottom.
It's going to be on bottom. Why do you think that?
Because the value is much lower.
Well, try again. Take another guess. Well, square roots look like this, Scott.
Right.
So it's going to be on top. And if you would plug in like, like say 1/200th, you have to really know that square roots look like that. And you know, Scott, if you would have graphed it on the calculator, you would have seen that it was on top. But and if you would have done it, okay, if you would have done it like this, and you came out with a negative answer, you would have known that you messed up and you had the wrong one on top. You know what I mean?
We started over.
Right, exactly. And if you start over, you have to start all the way over with rewriting the integral, okay? Okay, now Scott, it's okay. You're still doing good. Here's the hard part. How would you integrate square root of 2x? Just give me the final answer. Just give me the final answer to the integral of square root of 2x. Actually, we're just finding the area here. This is just the area of this region. I skipped not the volume. We'll do the volume with the next person.
4/3 x to the 3/2.
Okay, so you said it's 4/3 x to the 3/2? Well, if you wanted to integrate just square root of 2x, one way you could do this, say u is equal to x, du is equal to dx. So it's 1/2 times the integral of u to the 1/2 du, which is so it's u to 3/2. So it comes out to be 1/3 u to 3/2, or 1/3 times 2x to the 3/2.
Mm-hmm.
This is one way to do it. That's one way to do it. Another way to do it is to realize that the square root of 2x is equal to square root of 2 times square root of x, which is square root of 2 times x to the 1/2. And when you integrate that, you get square root of 2 times 2/3 x to the 3/2. Either one of these answers would be correct.
I gotcha.
Do you see that?
Yeah.
Okay. So if you wanted to find the area, you'd integrate this, and let's just do it this way for now. It's 1/3 times 2x to the 3/2. What's the integral of 4x?
4x squared over 2.
So it's 2x squared, and from 0 to 1/8, and then you plug in the numbers, which is a little bit ugly, but you'd plug in the numbers and get the answer like that. But don't, and also you could of course do that on the graphing calculator, right?
Yes.
If we plug this in, you would get 1/3 times 1/4 to the 3/2 minus 2 times 1/8 squared is 1/64. The zeros cancel out. Do you know what 1/4 to the 3/2 is? What's the square root of 1/4?
1/2.
1/2, and then 1/2 cubed is 1/8. So it's come out to be 1/24 minus 1/32, and you could leave it like that, or you could find a common denominator, which would be 96, and simplify from there. Okay?
Laura Pearson's here.
Laura Pearson's here. We'll tell her to hold on the line. We're going to go to another caller real quick, all right?
All righty.
Ellen Bray or Ellen McNamara?
Hello?
Ellen Bray or Ellen McNamara? Ellen?
Hello?
Hi, Ellen, can you hear me?
I can, no.
Are you watching TV?
Yes?
Turn the volume up on the TV.
Hello?
You can't hear me through the phone. You'll have to turn the volume up on the TV.
I did.
And you can't hear me?
I can hear you now.
Okay.
This is so weird.
Is this Ellen Bray or Ellen McNamara?
This is Ellen McNamara.
Hey, Ellen, what's going on?
How are you doing?
I'm doing fine. How are you doing?
I'm good.
Did you hear Scott Kittner on that last call?
Yes, I did.
Uh-oh.
He should be at golf practice right now.
He should be at golf. Well, what about you? Aren't you the district golf champ or something?
Yeah, well, I'm going soon after I call in.
After you call
After I talk to you for a while.
Now that is dedication. Ellen?
I know. What?
This is the problem that we just did?
I know.
You know?
Uh-huh.
Wow. Are you at home or in Miss Bishop's room?
I'm at home.
Okay. If you have square root of 2x and y equals 4x,
Yes.
this is what the region looks like. This is the line. This was a curve. That's what Scott just did. If we rotate this about the x-axis,
Yes.
just set up the integral that will find the volume of this figure.
Okay.
How would you set
Well,
up?
there's going to be a hole.
Going to be a hole. So what are we going to write
So
down?
pi,
Uh-huh.
the integral of 0 to the 1/8.
Okay.
And then big R squared minus little r squared
Okay.
dx.
Okay. And then what's big R and what's little r going to be?
Big R will be square root of 2x.
Square root of 2x. So it's square root of 2x squared. So we'll just put down 2x. Excellent. This is too easy for you.
I know.
And what's little r?
Little r, 4x.
It's 4x. Excellent. Isn't this exciting?
Yes, it's so exciting.
Aren't you going to like call in every week now?
Of course.
Hey, Ellen.
What?
You know what I got?
What?
How about that?
What's that?
That was a bell. Ellen, have a good time at golf practice. Great job.
Thank
See
you.
you Saturday, okay?
Okay.
Right.
Bye.
LaGeorge,
Yes,
how you doing?
fine,
You ready for a problem?
I guess.
You guess?
Yeah.
How about a volume problem?
I don't want that.
You don't want this one? Why not?
I want a separate differential equation.
You want a,
Huh?
you want a what?
No. A what?
Huh?
a separate differential.
Separable differential
Yeah,
equation?
it's hard to say.
Separable. Hold on, separable differential equation. Okay. So how about we'll do, oops, wrong one. How about dy dx is equal to x squared y. Find y if when x equals 1, y equals 1. How about, yeah. What was that? Who's talking in the background?
Sandy.
Sandy Macon?
Yeah,
Sandy Macon.
yeah. Okay, you're gonna move the y over, so it would be dy divided by y equals x squared dx.
Okay.
And then integrate both sides.
Okay, what's the integral dy over y?
Natural law.
Natural log of y.
And then x cubed divided by 3
Okay, plus
c.
plus c. Okay, what do we do now?
Yeah.
Well, what about, let's find c first. We can e it, but let's find c first. You want to e it first?
What?
You want to e it first?
Yeah.
Okay, what's e to the natural log of y?
Y.
And what? How would we simplify this?
Oh, put the c in front.
Okay, we'll make e to the c, we'll call that another, we'll call that like, this is like c1, we'll call e to the c big C. So it's,
It should be times.
it's plus up, yeah, you're right, it's times, thank you. I heard Miss Arthur back there.
Yeah.
So it's c e to the x cubed over 3.
Yeah.
All right, so what do we do now?
Plug in 1 for x.
So we plug in 1 for x and 1 for y.
Yeah.
Okay, I'm gonna move it up here. So we got y is equal c e to the 1/3, or 1 is
To the
equal
one-
c e to
yeah.
the 1/3. So what does c equal?
1 divided by e to the 1/3.
Okay, so c is equal to 1 divided by e to the 1/3, right?
Yeah.
So the final answer is y is equal to 1 over e to the 1/3 times e to the x cubed over 3, right?
Yeah.
Is that right?
Yes.
Sure looks funny, doesn't it?
Yes, it does.
See, yep, that's right. That's the right answer. Right answer. How about that?
How about
Isn't that pretty exciting?
Yes.
Yeah!
Woo.
You ready for your test tomorrow?
What you say?
You having a test tomorrow?
Yes.
All right, we'll keep calling in and we'll review you some problems that might be on there, okay?
Okay.
Bye, George.
Fine.
Kelly Raspberry?
That's not funny.
Hey, Delbert, do you ever listen to Kiss FM in the morning? Does anybody back there listen to Kiss FM? Listen to this girl's voice. It is exactly Kelly Raspberry.
Oh my god.
Hey, Laura,
Yeah.
say something. Come on.
Mr. Tate wanted me to tell you
Say
that.
it's 8:20 in the morning, and here's Luke with Skywalker Traffic. What? Laura,
Mr.
you
Tate
got,
wanted me to tell you that we missed 2 phone calls on Phone Flash because I was trying to get on the show. So.
hey, it's journalism. Who cares? All right. The journalism, it's for someone who's national journalism teacher year. All his students do everything. He doesn't do a thing. So it's really sad. I mean, I don't know how he gets these things.
Okay, but just for that joke, you have to give me an easy problem.
I'm going to give you an easy problem. You know why?
Why?
Because you're Laura Pearson. Actually, it's not going to be that easy.
Thanks a lot, Mr. Fleischer.
That was a compliment.
Oh, okay.
Gosh, it means that you're a nice person. Okay, I heard that. Dow was like valedictorian at like some school that had like 3 kids in his graduating class. All right, let R be the region enclosed by y equals x squared, x equals 2 in the x-axis. Okay, so in the first quadrant, I should say. Enclosed in the first quadrant.
Get the problem right at least.
All right, yes, dear. Fine, so what would the region look like?
Okay, it's going to be a parabola,
All right?
and then it's going to be a line through x. Is that x squared?
Yeah.
Or x equals 2, a line through x equals 2.
Okay, yeah, and actually I didn't need to put it in the first quadrant. I kept on changing the problem around. So it would be in the first quadrant if it's bordered by the x-axis also. But actually you needed to say in the first quadrant. Never mind. So if this is x equals 2, what is this point right here? Oops. What is that point right there? Hint, hint.
It's going to be 4. Is
Yeah.
that I can't read the TV.
Okay. You believe there's a long cord. So we're rotating this about y equals 4. So actually this problem is not that easy. But you're going to do it for us, okay?
All right.
Yeah, this is, if you could get this is, you get a, did you hear Ellen McNamara call in?
No. Well, what?
Okay, never mind.
Yeah, I heard Ellen.
How do you do the problem?
Okay. You're going to do pi and then integrate big R squared minus little r squared.
Okay. Excellent, excellent.
And then, well, I can't really see the problem.
Okay, what I'm going to do is I'm going to draw it much bigger, okay? Because I know you're like in the journalism room and you can't really see. Okay, and we're rotating this about the line y equals 4. Can you see it now?
Mm-hmm.
So you said pi, big R squared minus little r squared.
Mm-hmm.
Is it going to be dy or dx?
It's going to be dx.
Very good. It's going to be 0 to 4 or 0 to 2?
0 to 2.
Excellent. Okay, and what's big R? Here's the hard
Okay.
part. What's big R going to be?
Is it 4?
It is 4, right, because it goes from the line you rotate about to the outside curve. Hopefully you can see that it's just a slice. And so it's 4. And what's little r going to be?
4 minus y.
It's 4 minus this y value, and this y value is what? If it's in terms of x, what's the equation of this curve?
It's x squared.
So it's 4 minus x squared. Excellent. That's great, Laura.
Well, Alan's kind of helping me.
Who is helping you?
Alan Ricks.
Alan Ricks he has this thing down, you know that?
He does.
He does. He is a revolving, rotating man. Have him call in again, too, okay?
Okay.
Laura, great job.
All right.
Bye.
Bye-bye.
Bye-bye. Do we have another caller before I hung up on her? Hello?
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 Hey, it's Wes from WTY.
Hey, Wes, what's going on, man?
Not much.
Why are you laughing?
Because Hannah's laughing.
Oh, Hannah?
Do you have an exponential growth or decay problem for me like I asked for yesterday?
You know, you sure did ask for it, and I can't believe that I don't have one. But you know what? I will right now. Okay? This will take 2 seconds here. In 1980, there were, how about 220 people in the town of Ferris. In 1990, there were 270 people in the town of Ferris. If the population grows based on the model that the rate that the populations change is proportional to the population at any time, what do we project that the population in Ferris to be in the year 2000?
All right, well, the first thing you need to do is use sect to find it.
Use what?
CE to the KT.
Okay, I thought you said something else. Okay.
Ms. Harmon calls it sect.
All right. So you're right. If the population grows proportional to the amount that's present, it's that, and that when you solve for that comes out to be y equals CE to the KT. Okay. Then what do we do?
If we use 1980 as the initial, then we can set that as C.
Okay. So what does C equal?
220.
Boy, Wesley, you will not be stopped.
And then you would use 270 as Y.
Okay. So 270 is equal to 220 e to the what?
To the 10K.
To the 10K. Okay, then what do we do?
Then first you divide both sides by 220.
Okay, so we got 27 over 22, great example, is equal to e to the 10k. But we are not going to simplify. We're not going to use a calculator. What do you think of that?
And then you next you have to take the natural log of both sides.
Okay, Wesley, this is too easy for you. So this is 10k, so what does k equal?
K equals the natural log of 27 20-seconds divided by 10.
Excellent. Okay, so what's the population in the year 2000?
We plug that back into the initial, so you have y equals 220 e to the 20, and then the natural log of 27 20-seconds over 10.
So 20 over 10 is 2, so the answer is 220 e to the 2 natural log of 27 over 22. You know, we could actually do this because 2 natural log of 27 over 22 is equal to what? How would you simplify 2 natural log of 27 over 22?
Multiply it, you square the whole thing.
A natural log of b is natural log of b squared, so it comes out to be 220 e to the natural log of 27 over 22 squared. And what is e to the natural log of 27 over 22 squared equal?
I'm not sure.
E to the what's the formula? E to the natural log of u is
Oh, it's
equal to
just the
what?
stuff.
What's that?
So you bring down the 27 over 22 squared.
Right.
So it'd be 220 times
Right, so-
27 20-seconds squared.
Right, and I think 27 over 22 is approximately probably about 1.5, somewhere around there. So it's 220, and you can figure it out. It's probably like a little bit more than 1.5. So its population would be a little bit over 330. It's times 27 over 22 squared, and we can actually figure it out. So the population in Ferris, Texas, be about 330. Let's actually do that on our calculator. We got I got 331. Isn't that exciting?
Yes.
Hey, Wes, truly a fine job, Wesley. Fine job. I'm still
Thanks.
waiting for that theme song, Wesley.
All right.
All right. Good job, Wesley. Call in again.
Okay, bye.
Hi. Hi, I heard you've been asking about me, so I decided to call. Hi, Mr.
Hey, where you got a college scholarship, academic or athletic next year?
Athletic. Athletic.
Where are you playing soccer next year?
Antelope State.
Woo! Hey, what type of problem do you want?
It doesn't matter.
You know, that's what the fans are going to say that, you know, next year when they're watching you play soccer.
Yeah, I hope.
Yeah. You want, what type of problem did you want?
Anything
Anything, okay.
for the test
Anything for the test.
tomorrow.
Anything for the test.
Anything for the test.
And then, what is that from a play or something? What?
Tomorrow, you're only.
Oh, is that from Annie or Tomorrow or something? Annie? I hated that lyric.
Oh no.
I hated Annie.
Let R be the region included.
You're getting tackled.
Okay, let me read this to myself.
Okay. Alan Ricks, call out in.
Huh?
I was just yelling. Don't worry.
And the what axis?
X-axis.
Okay. Somebody's being mean. When the volume is all R. Okay.
Anything for... Mike, you know that song?
Okay, graph
And Annie?
it first.
Anything for you.
Graph it first.
Yeah, okay.
Okay.
Graph it, all right. Yeah, is that Miss Arthur again frustrated?
Yes.
Gosh.
Patience.
I know. Tell her to. All right. So we're rotating about the line x equals -1, right?
Right.
Wait. Don't tell Miss Arthur that you can do.
That wasn't
Tell-
Miss Arthur.
Well, whoever it is, tell her you could do it by yourself. You don't need any help. Okay.
I'm not telling them that.
All right. Well, so
There's a hole in the graph.
there sure is. So what do we do?
Washer.
Washer. Wash on, wash off.
Right on, right off.
Okay? So if it's a washer, that's the formula, right?
Right.
Is it going to be dy or dx?
Dx.
It is
dy.
going to be dy. The reason why it's going to be dy is because it's like it's parallel to the y-axis. And if you take an infinite amount of these little washers, you're slicing. The thickness is going to be the little space in y, if you could see that.
Right.
So here's the key. Is it going to be from 0 to 4 or 0 to 2?
What?
Is it going to be from 0 to 4 or 0 to 2?
To 4. 0 to 4.
That was the key. Okay. I'm in a closet. They put me in a closet. Can you believe that?
We can't really hear you that well.
How about if I talk louder?
That's good.
Okay. Vishaka. Vishaka.
Yes.
What's big R? What's little r?
Big R is... Um, 3.
3. What I do is I draw from the line that I rotate about, I draw it to the outside curve to find big R. And I notice that this length stays the same, so it doesn't vary. And that the length of this is 3 each time. Okay? And now what about little r?
Little r is... I don't know what little r is.
Okay, this is what I do. Vishaka, to find little r and big R every time, 100% of the time, I draw a line from the line that I rotate about to the original inside curve.
Okay.
Okay, so, and then this is all little r. Does little r vary? Does it change? Does this?
Yes.
It does. So if it changes, you're going to have a variable. What is the length of this line in general? Or what's just the length of this line right here? What's the length of that?
F of y?
Yeah, it's whatever x is. Okay? I mean, it's whatever the length of this is dependent upon x is. And what's the length of this?
F of y plus 1.
Right, it's x plus 1. That is what little r is. It's whatever x is, it's x plus 1.
Okay.
Okay, now the only thing is you have to put it in terms of y because it's dy.
Okay.
Well, so then if this is y equals x squared, what does x equal?
What was your question?
If this curve is y equals x squared, what does x equal?
Square root of y?
Yeah, so that's the final answer. It's square root of y plus 1 from 0 to 4 of pi dy. And I just, 3 squared. And that's all you do. But if you have trouble finding little r or big R, what I do is...
Yeah, that was my problem.
What you do, if you watch on the next... Put someone else on the phone and Well, actually, you know what? Let's stay on the phone. Just you and me for a second, okay? Let's stay on the phone for 1 second, and let's do a quick problem together, okay?
Okay.
And I want to show you that. And Hannah, hold on, Hannah. Don't.
Ask him what? Didn't you say ask him something?
Okay. Hannah, hold on for a second, Hannah. Don't get frustrated. Okay, we're going to do the same region, Vishaka. Same region, y equals x squared, and x equals 2. And we're going to rotate this region about the line y equals -1, okay?
Okay.
So first thing that I look at is that there is a hole, okay?
Okay.
You see that there is a
Yeah.
hole? Okay, there's a hole. So if there's a hole, it's pi r, big R squared minus little r squared.
Right.
And then what I do is I determine is it dy or dx. And you know how you could tell if it's about the x-axis or something parallel to the x-axis, it's dx.
Okay.
All right? And if it's dx, you use x points.
Use what?
You use the x points on the
Okay.
x-axis. If it was about, like the last one was dy because it was about the line x equals -1, which is parallel to the y-axis.
Right.
Okay, now that's the easy part. Now the hard part is, well, I mean, every time. Wait, hold on, Vishaka, seriously. If there's a hole, this is the formula, and it's easy to tell if it's dy or dx, and the limits are easy also. It's just if it's dx, use that. If it's dy, use that.
Okay.
And now here's the key. To find, I'm redrawing the picture, to find big R, what you do is from the line you rotate about, you draw it to the outside curve.
Okay.
Does this line vary at all?
Yes.
Yeah, so what is the length of this line in general terms? Oh, no help from anybody there. In general, what is the length of this line?
Y plus 1.
Excellent, it's y plus 1. And since we have it in terms, so we could even just put y plus 1. We could worry about the variable later.
No, well, no, wait. What would the variable? It
Well,
would
we
be
have
X.
to, what do you think? If this is y, and this is the curve y equals x squared, what do you think we'd have to substitute in for y?
X squared.
Right, we have to put it in terms of x. Well, y is x squared, so it's just x squared plus 1 squared.
Okay.
And then little r, what you do is you draw from the line you rotate about to the inside curve,
Okay, which
Okay.
is just -1.
which is just 1.
Oh,
Right.
1.
I mean, the length of that's just 1. So that's the answer, 1 squared. And that's how you do it.
Dx. Okay.
That's all it is. But every time, and you could worry about changing the variables later, but you always change the variable from the original curve, okay?
Okay.
Hey, Vishaka, we're gonna do a lot of the problems the next half an hour, so just keep on doing it. What did Miss Arthur say?
No, hi.
She said hi?
Yes.
Okay,
She was talking to Angela.
okay. But we'll keep on doing this, okay?
All right. Thanks, Mr. Fly.
Thank you.
Bye.
All right. Hannah!
Hey, what's up?
Yeah, what's up, dude? What's going on?
I've been asked to have you play the calculus song.
You know, we're in a closet. Okay, hey, Delbert, can we show where we are again? Delbert? Hey,
Sorry about that.
I know, they put us in a closet.
But
We
you have
got-
a giant calculator. Who could ask for anything?
Well, you know, actually, here, hold on. Oh, stay there. Oh, I gotta keep the wires with me here. I can't reach it, but it's a prop. You know, hey, Hannah, that's television talk, okay?
Okay.
You know, we're a multi-million-dollar production here, okay? We got sponsors all over the place.
We'll keep it on the DL.
Okay. The DO?
Never mind. Okay.
Okay, the DO. I'm a little worried. Hannah, what type of problem you want? Volume? Good, that's what I have.
Oh, fantastic.
No.
Got time?
What?
Nothing. Okay, let's do volume.
Okay, you're having too much fun. It's because you're in calculus with Miss
Oh
Hyman.
man, can I
Can
I not do volume?
No, but this is good. This is good for you. Because I like it when the WTY people say X talk or Y talk.
I've never done either.
Hey, I'll give you an easier
Okay.
one. I'll give want a little easier one.
Okay.
Actually, I don't have an easier one. Oh yeah, I do. Here you go.
What?
Actually, it is a little harder one, but it's okay.
What? No, it's like the same one.
It looks the same one, but it revolves about something different.
Oh my gosh. Okay, let's just do it.
Go, Crest.
All right, Y talk. Change everything to Y talk.
From where?
What? Never mind. Let's just do a picture.
Hey, could you like step away from the?
Yeah, something. Sorry.
That hurt my ear. Hannah. Okay, let's don't have a calculator on this one. How would we know which curve is on top?
Wait, you graph it?
Okay, and how would we graph this if we don't have a calculator?
You make a chart and plug in your points.
Hey, you know what? That's exactly what I would do. When x is 0, that's 0. Well, we know what that looks like, right?
1, 2, 2, 3, 3.
Okay. Well, and so, and what about this one? What is e to, like e to the 0 is what?
Is 1
What's e to the 2,
e to the 2?
approximately?
Fantastic question.
Take a bet.
It's 3 squared.
Yeah, it's something like 3 squared. That is
Something
excellent.
like 2.7.
Ooh. So the border on the left is x equals 0, the border on the right is x equals 2. So the region looks like that.
Right.
Okay, here you go.
Guys, I can
Actually,
hear.
you know what? Let's make this, let's change it.
Thank you.
Okay, let's change this to
That's awfully nice.
to x talk. All right, so here you go, you're up. Set up the integral. Revolve it about the x-axis. What do we do?
I'm sorry, I couldn't hear. She's turned up the TV because I couldn't hear.
Okay, revolving about the x-axis. What do we do?
What do you mean, what are we
I
doing?
mean, I set up the integral. Help me.
Yeah, you set up an integral. Okay, I'm sorry. It's
Yeah.
0 to 2.
0 to 2.
Integral from 0 to 2
And you know why it's 0 to
of
2?
the top curve. Well, just because it is, because we're around the x-axis.
Yeah, why did you say x talk? All right, go ahead.
X talk.
All right.
X talk. Of the top curve minus the bottom curve, but each squared. So big R is it's e to the x. Yeah, it's on top. So square that minus x squared dx.
Okay, that's excellent. Now,
dx.
I got it right here. I got it.
Oh, I didn't see it. There's a big glare on the TV. I'm sorry.
Big glare. Okay, here you go. Without a calculator, of course, if you had a calculator, it's pretty easy to do. We just do math 9, right?
Right.
How would you integrate this without a calculator? No help from Jake Meyer.
He's not here.
Oh,
He's
my
sick
goodness.
in bed.
Oh no, I hope he's watching at home.
How do you integrate that? I don't know.
Hey, how would you simplify this first? How would you simplify
Simplify it first. You multiply x times 2, so it's e to the 2x
That's excellent. So,
minus x squared.
okay, now what is the integral of e to the 2x? No, see if you can do it by yourself. I asked it's without any help, see if you can do it. Could you tell them to not do the announcements on my show?
I'm sorry, we had an intercom interruption.
I understand. What's the integral of e to the 2x? No help.
The integral of e to the 2x is e to the 2x. But then you have to have a 2 for your dx, and so you put a 1/2 out front. So it's 1/2 e to the 2x.
Woo! That's excellent. You know, Hannah, if you're really good with derivatives, you don't even need to know how to integrate, because if you know the derivative is really good, you know the derivative of this is e to the 2x, so therefore the integral of e to the 2x is that.
Cool.
So therefore, it's like
X
that.
cubed over 3.
Okay, we're still not out of the woods yet. We're in the closet, but not in the woods. Okay.
Okay.
All right. So how would you keep going with this?
Okay.
What's
plug
the
in 2.
Plug in 2. Okay. So what's that?
E to the 4.
So it's e to the 4th divided by 2 minus 8/3. Is that
8/3.
is that the final answer?
Right. No.
Ooh.
Then you got to subtract 1/2 times 1, which is 1/2 minus 0. So it's just
right.
pi over 2.
Yeah, that's why a lot of times it's excellent, and I'm going to just leave it factored out like that. A lot of times when students see zeros there, they just say, oh, it's 0, but you got to plug that in also, right?
Right.
Hey, Hannah,
Yeah.
you know what I could say? Fine job.
Thanks.
That's excellent. Call in again, all right?
See ya.
Do we have a caller? Preeti?
Yes, Mr. Fleischer, how are you?
How are you doing, Preeti? Are you sad there's
I
no...
can't hear you.
Preeti, turn up the TV.
Oh, I did. Thank you. That helped.
Okay, yeah. Hey, Preeti?
Uh-huh.
Are you sad there's no tutoring in the morning?
Yes, very sad.
The only last day where there's no tutoring is very sad. Rest of the year. You ready for? I gotta give you a hard problem though.
Oh, no. I want 5 points, Mr. Fleischer.
I know, but gotta give you. Sorry, that's
All right.
Okay, you are Preeti.
Oh, my
Isn't
God.
that pretty?
Yeah, that looks something like I've never seen before.
Okay, an oil storage tank.
Okay.
There it is. Nice drawing too.
Uh-huh.
Has the shape shown above obtained by revolving the curve y equals 9 over 625 x to the 4th from x equals 0 to x equals 5 about the y-axis, where x and y are measured in feet, oil flow into the tank at the constant rate of 8 cubic feet per minute. Find the volume of the tank.
I guess first you would set up the integral.
That's what I would do.
Would you do it from 0 to 5? I don't think so. Okay. Just a second.
Wait. Let's relax for a second here. First of all, is there a whole, let's go through your steps.
Okay. If you do it about the y-axis,
All right?
if you revolve it about the y-axis,
All right?
is there a hole?
You tell me.
No, there is a hole.
Like this is y equals 9 over 625 x squared.
Okay.
Okay?
Uh-huh.
So we're revolving this region about the y-axis right here.
What's that line that's dividing the...
This?
No.
This is the y-axis.
Oh, that's the y-axis. Okay, I'm confused. No, there isn't a hole.
Okay, so if there's no hole, what's the formula?
It's pi integral of r squared.
Okay, very good. Now, are we dy or dx?
dx. No, excuse me, dy.
Okay, so we're dy, pi r squared dy, okay. So if we're dy,
Yeah.
what points are we going to use?
Wait. I guess, what's the equation now? 9 over what?
625 x to the 4th.
Okay, wait. 9 over 625.
X to the 4th.
Okay, what are the points? I can't really see.
This says this is x equals 5 right here.
Okay. Just a second, Mr. Fleischer.
Okay.
I'm trying to figure this out.
That's all right.
Okay. Would 9 be a point for 5?
9 sure would be, because 5 to 4, so
Yeah.
this is 9. So this is 0 to 9, and then 0 to 5. Are we going to do 0 to 9 or 0 to 5?
We do 0 to 9.
I'd do 0 to 9, okay? And what is R equal?
R would equal just 5 minus x.
What is R equal?
Am I not right?
Nope.
Okay.
What do we do?
You draw the line from an outside curve to the line you're rotating about.
Okay, so
So-
what's the length of this line?
It's varying. Oh, that's just x. Never mind.
Okay, so it's just x.
X, yeah,
So
squared.
it's just x, so it's x squared. So if it's x squared, we got to put it in terms of y. How are we going to put it in terms of y?
First you divide y divided by 9 over, I guess, yeah, 625 over 9 times y.
Okay, and what are we going to do now?
You fourth root it.
Well, since we want to solve for x squared, let's just take the square root.
Okay.
What's the square root of 625?
Let me see. Just a second. It would be 25.
What's square root of 9?
Yeah, is 3.
So therefore, x squared is 25 over 3 square root of y, right?
Mm-hmm.
So it's pi from 0 to 9 of 25 over 3 square root of y.
Okay.
How do we integrate this, square root of y?
You would put y to the half,
Okay?
and then so you would have y to the 3 halves over
So
3
I
halves.
come up with 50 over 9, because this is y to 3 halves, 2/3 y to 3
Yeah.
halves times 25 over 3. 50 over 9, y to 3 halves, from 0 to 9,
Yeah.
all that times pi. When you plug 9 in, what's 9 to the 3 halves?
9 to the 3 halves is 27.
So yeah, so it's 50 times 27 over 9, so the answer is just 150 pi.
Okay.
You see that?
Uh-huh.
Wasn't that fun?
Yeah.
That's a good problem.
Yeah, that is.
You're going to see that problem. You're going to see that problem when you start reviewing with that syllabus. You excited about Saturday?
Sure.
You pumped?
Yeah.
All right.
Am I getting 5 points, Mr. Fletcher?
Hey, I don't know. I don't know if you got the whole thing right there. We'll negotiate, okay?
Okay.
Hey, that's a great job, Preeti.
All right. Bye, Mr. Fletcher.
All right, Angie Carter!
Yes.
Who's a better soccer player, you or Vishaka?
Vishaka.
Really?
Yeah.
I don't know. I think it's pretty equal. What'd she say?
She said you haven't even seen us play.
Busted! Busted in the closet. Look at this here. Look what. I mean, this is like there's like my clothes. This is my home.
They wanted to know when you were coming out of the closet.
Hey, this is a PG-rated show. Coming out of the closet. I'm coming out of the closet at in exactly 18 minutes. Our producer's at 14 minutes. I don't know we only have 14 minutes left, is that right?
Yeah.
14 and a half minutes, I'm coming out. But I better be careful here. That's very good, Angela. What type of problem do you want?
Can I have a BC problem?
A BC problem, sure.
Yeah.
What subject?
What's one that I'm struggling in? Euler's method.
Euler, he doesn't care.
No, don't make him. No, never mind. Don't
Why? I have it right here.
Never mind, don't do that.
Why not? I'm doing it. I don't have to listen to her.
Because you do it different.
I do not do it different. Tell Miss Arthur, just for that, all right, fine, I'm giving you.
She can hear you.
I know she can hear me. That's the intention. I hope she can hear me. All right, here we go. dy over dx is equal to xy over 4. Okay?
Okay. So then I do...
Wait a minute. We don't know how to do that. My goodness, you're right. You do it differently if you know the answer before the question. Boy, that's some good teaching right there, I'll tell you. Okay, how about F of, okay, pressure, no pressure. F of 1 is equal to 2. Find F of 1.2, or estimate, this should say estimate, F of 1.2 if, with, how about delta x equal to 0.1? All right?
Okay.
Does that make sense to you, that
Yeah.
question? Okay. It should say approximate, you know.
Okay. So the delta x is the change in something. I don't know. Okay.
Yeah.
Anyways, I think we do the cross multiplying? Like where I get y's on the one side? No?
No, okay, you know what? Wait, Angela, wait, hold on for a second. Angela, you know, this is really good what you just said, because if we wanted to find exactly what f of 1.2 is, that's what we would have to do. We would have to do this. And the answer is natural log of y is equal to x squared over 8 plus c. F of 1 is equal to 2, so natural log of 2 is equal to 1/8 plus c. C is equal to natural log of 2 minus 1/8. So the correct answer, if you e both sides here, you have natural log of y. If you really wanted to find the exact answer, what you would do is you would e both sides. So y would be equal to e to the x squared over 8 plus natural log of 2 minus 1/8, and then plug 1.2 into there.
That was if I wanted the exact, but I don't want the exact.
Right. So that's a really,
No.
but we're using Euler's method to estimate this. But this was for the AB people. If you wanted to find f of 1.2, that's what you would have to do.
Yeah, but
Of course, you could simplify that.
What could be on your kid?
Okay. So I think okay that's the delta x equals 0.1 is the change. So
Change.
you start it like at f of 1.1, right?
No, we always start at the initial point. You always start at f of 1 equals 2. You always start.
Okay, so the f of 1,
So we start at the
equal
point
2.
1, 2.
f of 1 equals 2,
Right.
right?
We start at the point 1, 2. What's our little tiny slope going to be?
Our slope is going to be 0. Just kidding. Okay, the slope is going to be
At the point x,
1/2?
Right. At the point 1, 2, the slope at that point is 1/2, but we're going to extend it all the way to 1.1 of a slope of 1/2. Okay?
Okay.
So now here's the key. What is this y coordinate? If this slope is 1/2, what's that y coordinate?
1 equals 2? 1, right?
1
1 plus x times y divided by 4 times delta x.
Well, okay, you're right, Angela. I do it a little differently. This is what I do. So
Okay. Can the slope just be 0.5?
we know that delta y over delta x is 1/2,
Ow!
right? Angela, delta y over delta x is 1/2.
Yes.
So what is delta x here?
Delta x is 0.1.
So delta y over 0.1 is 1/2. So therefore, what does delta y have to be? Or if delta y is equal to, if this is equal to 0.5, what does delta y have to be? If you multiply both sides by 0.1, you get delta y is 0.05.
Right.
So therefore, this has to be 2.05. Okay, see, I don't really look at it as a formula, but so what you do is you know that the slope is 1/2, so then from there, you know delta x, and you just have to find delta y. And then once you get here, what you do is you're going to multiply, to find the new slope, you're going to multiply 2.05 times 1.1, which is going to be, it's going to be, if you, 2.05 times 1.1 is going to be 2.255. I'm confusing you, aren't I? Angela?
Yes.
I'm confusing you, aren't I?
Yes.
Okay. If you do it, well, I mean, the way you were doing it before, if you can't find, you have to be able to find this point in order to keep going on. You can use the system, but here, actually, hold on one second here. Let me try this one more time. Okay. Yes. And give me 1 minute. Okay. If Miss Arthur would be nice, and let's say f of 0 is equal to 1, and let's say we're trying to find f of 0.2. All right.
Okay.
So this is the point we start at, 0, 1. We start at 0, 1, okay?
Okay.
Now, to find the slope, you got x equals 0, y equals 1. What is the slope?
0.
It's 0, right? So you would make this slope of 0. So at x equals 0.1, what's the y coordinate?
1.
See, you have to know that if this is 1, then this is 1. If this is 0, 1, it's a slope of 0, then the point at 0.1 is also 1. You don't see that?
Yeah.
Just say yes. Is that Miss Arthur again? And Angela, if this is the point, 0.1, comma 1, how would you find the new slope?
You would put it in the equation.
So you got 0.1 over 2. Well, 1 over 2 is 1 half, so 0.1 over 2, which is 0.5, 0.1 over 2 is 0.05.
Okay.
Okay? So here's the answer. This is a slope of 0.05. How would you find this y coordinate? And that's what you're looking for. How would you go about finding this y coordinate?
You do the f of... Okay, you start with 1 and add on a new chain, 0.05.
Okay, yeah. Look at it this way. Let's start this for a second. Angela, if this is 1, if we're making up a new problem, if this is 1 and this is 4, and this is 3, if this is a slope of 2, how do you find this y coordinate? If this is a slope of 2, how do you find this y coordinate? Because you're just memorizing the formulas, but if this is 1 and this is 4, and this is a slope of 2, how would you find this y value? What would you do?
I don't know.
Okay, what's the formula for slope of a line?
Change of y over change in x.
Right, so it'd be change in y over change in x is equal to 2. Did you see that?
Okay, yeah.
And then solve for that. And that's all you're doing right here. If you know this line is 0.05,
Uh-huh.
and we'll call this y.
Minus 1 over 0.05.
It's 0.2 minus 0.1, which is 0.1, is equal to 0.05. That's right. Then you multiply this, you get y minus 1 is equal to 0.005. So y is equal to 1.005.
Okay.
See, and that's how you find it. If you just memorize the formula, it's really not that bad. If you just try to draw the slope, you can easily find the new y coordinate.
Right.
Okay?
Okay.
And that's all you're trying to do, all right?
All right.
Good luck. We'll see you Saturday.
All right.
Josh!
Yeah.
What type of problem you want?
I don't care.
Give me the BC problem.
Is this Josh Witt?
No, Josh Newton.
Josh Newton? Okay, Josh, here you go. You ready?
Yeah. Jennifer wants to see her dog.
Jennifer wants to see her dog? Okay, well, I'm gonna look for a dog while you're seeing the problem. How's Jennifer doing? How you doing, Jennifer?
I'm doing fine.
She says she's doing fine.
I heard her.
Oh, okay.
Okay, Josh, no calculator. See if you can do this.
Put the calculator away, John. Oh my God. Come on, that's so easy.
Whatever.
Integrate.
What do you think, Josh?
Okay,
you do the integral of, okay. You do the integral of 1 over the square root of x.
Is that Jennifer's dog?
Yeah, that's the dog.
Yeah.
Because we have Michael Lewis's dog too.
Oh.
You have the integral of 1 over square root of x
From 4 to 9.
from 4 to 9, right? And then how would you do that?
Well, 1 over the square root of x is the same as x to the negative 1/2.
Okay, which is what?
The integral of that is, what? 2x to the 1/2.
2 square root of x, right?
Yeah.
And then, so what's the final answer?
That's going to be 6 minus 4, which is 2.
So it's 6 minus 4, so the answer is 2.
Yeah.
Okay, that's great job.
Okay.
All right, Josh. Good job. Bye, Jennifer. Bye, Jennifer's dog. Hey, Cecilia. Where have you guys been?
I don't know.
How come you guys haven't called? We've missed you.
Part of I don't know.
What?
We were at the football game.
Football game.
Powder puff.
Powder puff. Okay.
I just mad because you don't have
All right, here we go. How many minutes do we have left? Okay. So here we go. X equals 2. Rotate this about, yeah. It's this, not this exact problem.
It's not?
Nope.
Okay.
Rotate, Cecilia, rotate this region about the y-axis. Tell me how to set up the integral. And you have a minute and a half.
Go.
I integrating from, we have to change it to y, don't we?
Yes, we do.
Square root of y equals x.
Okay. 0 to 4 or 0 to 2? Which one?
0 to 4.
Right, because we're slicing that way. Okay, 0 to 4.
Which is going to be 2 square.
Excellent. 2 squared, so it's 4 minus
Square root of y squared, which is y.
Excellent. Boy, that is too easy. Hey, if you had to finish integrating this, what's the integral of 4?
4x, 4y,
And what's the integral of y?
minus y squared over 2.
Plug
Times
in.
pi.
So it's 16 minus 8. So the answer is 8 pi.
Where's the thing going to be on Saturday?
Oh,
What's that?
The
You coming Saturday?
house on Saturday.
What's that?
The prep session.
That's right. You
where's
come-
the prep session on Saturday?
North Dallas High School.
Okay.
All right?
No, not really. Okay.
We'll see you guys Saturday, all right? Jaguar.
Yeah.
Okay.
What's up with the...
Okay, we'll see you guys on Saturday. Good luck with this is 5 weeks left. A lot of you are finished with the course if you're doing volume, so all you have to do is review the next 4 or 5 weeks, and it's automatic. Excellent. Hopefully we'll come out of the closet next week. Talk to you later.